So hello everyone, welcome to lecture 6 of the complex number. In this lecture we are going to learn about the important terms of the complex number. Just like the vectors, in vectors what we learned that there are two important things in vectors, right? One is magnitude, another one is direction. If we know the magnitude and if we know the direction, we can plot the vector, a unique vector we can get, and we can tell everything about that vector if we know these two quantities. Got it? Similarly, in the complex number also, there are total three important terms. What are the three important terms? The first important term is modulus of the complex number. Modulus, modulus of complex number. Modulus of complex number is denoted by mod of z. Got it? Next one is conjugate. Conjugate of complex number. Conjugate of complex number is denoted by z bar. And next one is argument. Argument of complex number. Argument of complex number is denoted by arg of z. Got it? So now one by one we'll learn about modulus, conjugate, and argument. So come to the first one, modulus of complex number. Modulus of complex number. It is denoted by mod of z. To understand this, let's take one complex number z. Complex number z. Z is what? X plus iota y. I told earlier also any complex number z represents a point on the complex plane. So if we will draw the complex plane, this is my real axis x and imaginary axis y. So in this complex plane, where is this point x comma will lie? This x comma y will lie somewhere here. Let the point lies here, x comma y. This is my complex number z. This point represents the complex number z. So what modulus of z tells? Modulus of z tells the distance of this point z from the origin. The distance of this point z from the origin. This distance is denoted by modulus of z. Now how to find the distance of this point from the origin 0 comma 0? So this distance will be equal to modulus of z, and modulus of z is equals to under root of x square plus y square. Got it? Any doubt? Now for example, if they have given, that modulus of z is equals to 1. Modulus of z is equals to 1 means the distance of this complex number z from origin is equals to 1. Got it? So tell me how many points are there like this whose distance from the origin is equals to 1 units? There can be infinite points, right? There can be infinite points. So this will make a circle. If all the infinite points you will join whose distance from origin is 1, so this will make a circle. Got it? Or you can write like this also, mod of z is equals to under root of x square plus y square. This is equals to 1, or x square plus y square is equals to 1 square, which is 1. This represents a circle with center 0 comma 0 and radius is equals to 1. Got it? Now next I'll take one more example. Suppose I'll write example number 2. Example 2 they've given, if suppose mod of z minus 1 is equals to 2. Got it? So here if you will write the value of this complex number z is equals to x plus iota y, right? So z I will take x plus iota y. Minus 1 is equals to 2, or this minus 1 you will subtract to real part. This we have learned in algebra of the complex numbers. So x minus 1 plus iota times y modulus is equals to 2. Or if we will solve this one, what is the modulus? How to find? The real part square plus imaginary part square under root real part square x minus 1 whole square plus y square is equals to 2. Or if you will do squaring both sides, you will get x minus 1 whole square plus y square is equals to 2 square. So what is this? This is the equation of a circle. This is the equation of circle. With center. Center is, what is the center? Center is 1 comma 0, and radius is 2. Got it? So if we will try to generalize this one, so we'll get like this. if we'll try to generalize this point, we'll get, suppose if they have given mod of z minus z1 is equals to r, that means this will represent a circle, a circle with center, with center as z1 and radius as r. Got it? Now next, if you have any doubt, you can write in comment section. Got it? I'll reply in that. Now next, you see, what is this z minus z1? This z minus z1, modulus of z minus z1, actually it represents the distance between distance between distance between complex number z and z1 in complex plane. In complex plane, if you will plot both the points in complex plane, it will give the distance. They are saying the distance between both of them is equals to r. Got it? Z is a variable point here, z1 is a fixed point. That's why we are getting a circle. Got it? Now next, if suppose they have given mod of z is equals to r. So what is this? Here you can say z1 is 0. Z1 value is 0. That means origin. So here this one is distance of z from origin. Got it? This complete equation here represents a circle. Circle with center 0, 0 and radius r. Yes, z was a variable point. Here z also was a variable point. Understood? Now, if they will write like this, z2 minus z1 mod. Actually, this does not represent any circle. This represents a, you can say, a length of a line segment. This represents a distance between 2 points. This is a distance formula, or distance between the 2 points. This is nothing but distance between 2 points z1 and z2. Got it? Now next we'll see some examples also. Suppose if I'll write a question. Suppose if I'll write a question, z plus 1 minus 3 iota modulus is equals to 3. Tell me what it will represent. It will represent a circle. Why? Because this I can write as z minus of minus 1 plus 3 iota, which is behaving as my z1, is equals to 3. So this represents circle with center. What is the center? Z1. This known point is a center. What is this known point? Minus 1 comma 3. So center is minus 1 comma 3. And what is the radius? The radius is 3. Radius is 3. Now suppose one more question else. I'll take this question. They have given z minus 1 and z plus 1 is equals to 4. What does this represent? This represents the distance of the point z. This represents distance of the point z. Distance of point z from what is this point? This point is 1 comma 0. From point 1 comma 0. 1 comma 0. Got it? What does this represents? This represents the distance of point z from minus 1 comma 0. Got it? Because here if you write, here I can write z minus of minus 1. Got it? This is minus 1 comma 0. This is a distance from 1 comma 0. This is a distance from minus 1 comma 0. Got it? Of the same point z is equals to 4. So if I will draw this, and z is a variable point, right? So if I will draw the axes, so here I am having this point 1 comma 0, and here I'm having a point -1 comma 0. Got it? And there is a some point z. There is a some point z. Let z coordinate be x comma y, or x plus iota y. So the distance of this point from the point -1 comma 0, the distance of this point z from the point 1 comma 0. Let this point be a and b. Got it? So this, and this point you take as p, which represents the complex number z. Got it? So what they have given? They have given that PA plus PB, this distance PA plus this distance PB is equals to 4. Got it? So tell me which locus this point Z represents, this point P represents. This point P will represent a ellipse. This point P will represent a ellipse. Got it? In ellipse only we have studied this condition. Okay? This we studied in ellipse only, that if we will calculate the distance of any point on the ellipse with the focus of the ellipse, the sum of the distance will be constant, and the sum of the distance is greater than this AB distance. Tell me what is AB distance? This AB distance is 2. So here I'm having 4. 4 is greater than 2, so it will represent a ellipse. Got it? So this actually is the equation of ellipse. Equation of ellipse. Tell me what these 2 points is known as. These 2 fixed points are known as focus of ellipse. Got it? Focus of ellipse. So here I can write this represents a ellipse with focus at -1 comma 0 and 1 comma 0. Got it? Any doubt till now? We'll see more examples. Now next we'll come to conjugate. So the first important term we have completed. What is modulus? Modulus is nothing but the distance between the complex number z and the origin. Understood? How to find this modulus? We will do the square of real part, and we'll do the square of the imaginary part, y, and then we'll put inside the root. Got it? To get the modulus. Modulus is always positive. Modulus of complex number is always positive. Right here, it is always positive. It will never be negative. Understood? Next, we have seen some questions, some examples in different cases. Sometimes it will represent ellipse. Sometimes it will represent the distance between 2 points. We can use this as a distance formula also between 2 complex numbers. Next, we have seen this when it represents a circle. Next, we have seen when it will represent an ellipse, how the equation of ellipse is written in the form of complex number. Got it? Now, next, come to conjugate. Conjugate is the second most important term we have to learn in this chapter, complex number. Got it? Now, what is a conjugate? Conjugate is very easy also. Suppose a complex number z is there. Complex number z is there, x plus iota y. So the conjugate is represented by z bar. Conjugate is represented by z bar. Suppose z bar will be formed by changing the sign of imaginary term or the imaginary part. What is the imaginary part here? Y. So y sign will change. Y we will change with minus y. So change here. What I'll get here? X minus of iota y. X minus of iota y. This is my complex number. Conjugate of the complex number z. Got it? So for example, suppose z is the complex number -3 plus iota. Now what is z bar value? Find z bar. One more question I'll take. Suppose z is the complex number -2 minus 5 iota. One more example I'll take. Z is equals to the complex number suppose z is equals to the complex number 5 plus 3 iota. So tell me what is the value of z bar here? So how to find? Z bar will be -3. What is the complex? The imaginary part here? Imaginary part here is 1 iota, right? So I'll write here -1. We'll change the sign. That's it. Here also -5 will change to +5. So z is equals to -2 plus 5 iota. Here z bar. Z bar here also will be equal to 5 plus 5 minus 3 iota. Plus 3 iota, we'll write minus 3 iota. So, some more examples you can see. If suppose z is equals to 5, so what is z bar value? Z bar value also will be equal to 5 only, because there is no imaginary part. So, no need to change the sign. If I'll write z is equals to 2 iota, so what is the value of z bar? Then z bar in this case will be equal to minus 2 iota. So if you will see here, in none of the complex number we will touch the real parts. While finding conjugate, no need to do anything with the real part. Real part, if it is negative, we will keep it negative. If it is positive, we will keep it positive. If it is 0, we'll keep it 0. Understood? No need to do anything with the real part. Only the sign of imaginary part will change to find the conjugate. Find the conjugate. Okay. Now one question we'll do. One example. Suppose they've given z, x comma y is a complex number. Is a complex number. They have given x is also positive, y is also positive. Is a complex number means this represents a complex number, x plus iota y. Got it? Now they are saying find and plot z bar minus z and minus of z bar. Got it? In the complex number we have to plot and then name the figure form. Name the figure and name the figure thus form. Okay. So now first we'll draw a complex plane. Suppose this is my complex plane. Got it? This horizontal axis represents the real part, and the vertical axis represents the imaginary part. Sorry, imaginary axis is known as imaginary axis. Got it? So where this complex number z will lie, as x coordinate and y coordinate both are positive, so it will lie on the first quadrant, somewhere here. Coordinates are x comma y. Got it? So what is this distance? This distance is x. Sorry, this distance is y. This distance is y. Got it? And this distance is x. Fine. Now next, now we have to find z bar. Z bar means what? We have to replace the imaginary part y with minus y. Got it? So here, where this z bar will lie? Z bar will lie in the fourth quadrant. Z bar will lie in the fourth quadrant. The coordinates of z bar will be x comma minus y. Got it? This z bar will represent the complex number x minus of iota y. Got it? So what is this length? This length will be equal to y only. And what is this length equal to? This length is equals to x. Got it? Now next, where is minus z? If z is here, the minus z will lie in the third quadrant. Yes or no? Because minus z means what? Minus z means minus x comma minus y. Both will become negative. And again, this distance is x and this distance is y. Now where is minus? This complex number minus z means minus x minus iota y. Now next, where is this minus z bar? Means minus of conjugate of z will lie. Conjugate of z is x minus y. So minus of conjugate of z will be minus x plus y. Got it? So it will lie somewhere here. This represents minus of mod z. The coordinate of this point will be minus x comma plus y. Got it? So this distance, if you will see, this distance again is y and this distance is x. Got it? So what is this figure? This figure is a rectangle. Figure is a rectangle, right? Because the opposite sides are 2x and 2x, and this pair of opposite sides are 2y and 2y. Understood? If x and y are equal, then it will be a square. Otherwise, now it is a rectangle. It may look like a square because I've drawn with freehand, but this is a rectangle because this horizontal distance is 2x, this vertical distance is 2y. Got it? Now next we will learn about argument in the next lecture. Got it? In this lecture we covered the modulus of the complex number and the conjugate of the complex. Modulus of the complex number we have seen how to find, And the conjugate of the complex number, we have seen how to find. We have done a simple question also. On conjugate of complex number, always remember, nothing we have to do. We have to change the sign of the imaginary part. That's it. Okay. So thank you. See you in the next lecture.